The second part of chapter 9 would be on composite body. Yeah. Okay. So we'll be looking at how to determine the center of gravity for and center of mass for the composite body. Okay. So application. Like example, the I-beam. This is an I-beam. Yeah. And this is a T-beam. I'm pretty sure that you have seen this in many places. Yeah. When doing a stress or deflection analysis on the beam, the location of the centroid is very important. So that's the reason why we need to find the composite body. Yeah. How can we easily determine the location of centroid? This is where I'm going to cover this particular chapter in. Yeah. Okay, and then let's look at these. Yeah, also like example, this compressor. Yeah, we need to find the centroid. Yeah, and this compressor is not just one unit, right? It's like one piece here, one piece here, one piece here. The pipelines. Yeah, this is the actual industrial assembly that it will look like. So you need to find where is the center of gravity for this kind of situation. Yeah. So how are we going to do that? Yeah. Let me just go through an example, then you will understand even better. Okay. So if you look at this kind of shapes, yeah, if you they are made of different shapes. Like, okay, this is like one triangle here, and this one is a rectangle. Okay, and then this one is a parabola, right? And then this one is a circle that is being minus from these two parts. So you can actually break it up into smaller parts for you to understand even better. Okay, so let me just go through an example. I'm going to skip the example in the slides because the examples in the slides are rather easy, but I'm going to go straight to the example in the textbook itself. Yeah, so let's look at the example in the textbook. Okay, let's look at the shape here. So we have ignore the units. Yeah, the units are in feet. Just assume that the units are in centimeters. Yeah, okay, because don't worry about non-SI unit. You only get SI unit. Yeah, so this is one shape here. So this is the shape. So what is it made of? Okay, so I've broken down into the first shape, which is the triangle, and then this whole piece here is actually a square, right? Because it's three feet here, 3 feet here. It's a square. Yeah, component 2 square. And what do I cut off? The rectangle. Can you see this part here that I've highlighted? Yeah, I've colored. So this is the place where we chop it off. So component third one is you chop it off. You throw it away. Okay. So if you look, component 1, area. So this is the table that you need to construct. I've gone through this with you during your lab class, right? Okay, this is a standard table that you need to construct. Yeah, just follow the table. Yeah, in all your exam and all. So you divide into segments. So this one, segment 1, triangle. So what is the area of triangle? Half times base times height. Okay, and what is the center for a triangle? Triangle always 1/3, right? So what is the coordinate? It is 1. Okay. So that's why it's 1. What about up here? It will also be 1 because the whole thing here is actually 3. Okay, where did I see 3? You see the question has given you. This is 3 and the height here is also 3. Okay, you understand? So we have y is 1/3 also. So area is half times base times height. Base is 4.5. So 1 times 4.5, 1 times 4.5. Keep that aside. Next we go to segment number 2. Segment number 2 is a rectangle, a perfect square. Not a rectangle, a perfect square actually. Okay, so we have 3 feet times 3 feet, 3 feet times 3 feet. So we have 3 times 3, which is 9. And what is the center for a what do you call, for a square? Half. So it's 1.5. And in y sector, it's also 1.5. 1.5, 1.5. Now let's look at it. Suddenly it has a negative here, right? Okay, where did it get negative from? If you look here, this is your axis, right? This is your axis, your y-axis. So all this side is positive, all this side is negative. You know that, right? So this is actually, the coordinate is actually on the negative side of negative side. That's why it's negative 1.5. Okay, so when you multiply, don't forget to write down the negative. That's very important because it determines the coordinate, yeah, whether it's in the positive side or negative side. So we have that 13.5. Yeah, how do you get that? 9 times 1.5. Yeah, 9 times 1.5. Okay, next, this rectangle is the part that we're going to chop it off and throw it away. Okay, so what is the area? The area here will be 2 and times 1. So 2 times 1. So go back here. We have 2 times 1. Now, why did you put a negative there? Because this is something that we're going to chop off and throw it away. So the coordinate is 2.5. How did you get the coordinate? Okay, half. So the distance is 2.5. Coordinate 2.5. Negative. And how tall is it? Okay, how high is it? Okay, it is placed somewhere 1.5, isn't it? 1.5. So wait a minute. So this is 2. Half of 2 is actually 1, but it's lifted up 1, so 2. So this is the center, 2. So it will be 2. So 2 times negative 4 will be negative 4. So this column here will be just addition. So what do you have? Negative 4. So negative 4 divided by area. 14 divided by area. So what do you get? Negative and positive. So this is actually the coordinate of your centroid. Okay, so let's do another example. This next example is volume. Almost the same concept. Yeah, so locate the center of mass of the assembly. The conical frustum has a density. So this given density. And the hemisphere density. Conical is 8. So up here will be 8. And hemisphere has got 4. So the bottom part is less denser, 4. Okay, so and there's 225 mm radius cylindrical hole. There is a hole in the middle. Okay, you understand? Okay, there's a hole in the middle. Okay, now we're going to break this down into smaller components. Okay, the first one is the cone. Okay, where do you get this information? You can actually get it all from here itself. Okay, what is the height? Yeah, and all. Okay, segment 1. Segment 2, segment 3, the part that chop off. So this is negative. And segment 4, which is also negative, because the part that chop it off, right? Okay, so how do you find the volume? Okay, where do you go for your volume? At the back of your textbook or in your formula sheet. All the formulas will be given, yeah? Yeah, so don't have to worry much about the volume. Like example here, can you see? Volume is 1/3 pi r square h. That's for the cone. Yeah, for the cylindrical, volume is pi r square over pi r square h. So volume will be given. So what you need to do is just need to plug in. Okay, now if you see here, they're actually finding the mass. Yeah? So how do you find the mass? Given to you density. What is density? It is megagram over meter cube. So megagram over meter cube, multiply with meter cube, you get megagram. Okay, so that's what happening here. But this unit is in kilogram. That's why it is actually written here as -6. Yeah, -6 over meter cube. Yeah, because it's converting to kilogram. Yeah, so 1/3 pi r square and h. That would be the volume. So you get all this in mass. Okay, so you do this for the first one, and then you do that for the hemisphere. That's the formula for hemisphere. Where do you get this? You get all this at the back of the textbook. Yeah, formula for hemisphere, that's the volume, multiply with the density. The density here is 4. Yeah, and then we have the volume for the cone, negative. Can you see again negative, because you're throwing out that part. Yeah, okay, so this negative and negative. Okay, since that this is symmetrical. Yeah, since that it is symmetrical, it means when you look at y-axis, it is actually running through yeah, correct. If you look through x-axis, it's actually symmetrical with the x-axis, and it's also symmetrical with y-axis. But the only thing that is differing here is the z-axis. So that's the reason why they have actually only looking for the centroid for the z-axis. Okay, you understand what I'm saying, right? Okay, because if you have a cone like this, okay, if you take up here this line here, this will represent your x-axis, correct? Okay, this location of your x-axis. So this is symmetrical. You understand it, not? Yeah, x-axis is symmetrical, but the z-axis has a distance. Z-axis is not symmetrical, so that's why it is actually looking for z. Yeah. Okay. Now, where do you get this? Where do you get this value now? Okay, going back to the table. Okay, you can find here. They would have given you. Can you see the h? H over 4. For y, it is h over 4. Means from the bottom, h over 4. So that is how you find the centroid for the y-axis. And even if you see here, sorry, this would be for your z, because it's vertical, right? H over 4 is for the z. The y and the x is actually symmetrical. Okay, going back to this. Okay. Okay, next you have the z value. You have all the z value. So the next line will be to multiply. Okay, so you just multiply. So what you have here is that this value here is just the multiplication between the first two. This value 50 with the 4.189. So you get all this value. So whatever this plus, you plus, whatever this minus, you minus, you get 45.815. So with that 45.185, what you need to do, you need to divide by the total mass. Where do you get the total mass? Here. So the centroid is 14.6. So looking at this diagram, so where is 14.6? The centroid will be somewhere around 14.6 from the somewhere around here. That is where the centroid will be. So that is the meaning of the value. Okay. So this is the end of this chapter. So what I expect you to do is, I have some questions for you to actually solve. Yeah. I posted it on the e-learn. Just look at it and solve it accordingly and submit your work. Thank you.